Algebra 2, Lesson 38, Part A is about powers of sums. Okay, and first a little reminder about an exponent rule. You know that x squared means x times x, and so xy cubed squared means xy cubed times xy cubed. You're squaring that whole thing. And here, everything's getting multiplied. It's x times y to the third. And then you're allowed to use your exponent rules to add the exponents, right? When you're multiplying x times x, you add the ones. And multiplying those y's, you would add those exponents. Your shortcut rule for your exponents would be when you have a power raised to a power, you multiply, right? So they understood 1 times 2 gives us the 2, and 3 times 2 gives us that 6. Okay, but this is a product. It is not a sum. That's different than this, for instance, because this isn't 3x squared times 4y, it's plus. This one's a sum, so we treat those differently. The squared that's on the outside here still means we take this entire set of parentheses times itself, so it's written out here, and then what we need to do after that is FOIL. We actually multiply those binomials the way the way you were taught. So you do 3x squared times each of those, and also 4y times both of those. So let's just go ahead and do that one. That is 9x to the 4th. We take those two, and then 12x squared y. And then we take 4y times this 3x squared, we get another 12x squared y. And then the last is 4y times 4y, which is 16y squared. Add the like terms. Okay, and you see that you cannot just square both of these terms because then you're missing that entire middle term. Okay, it would not be the same. And so this part is just a reminder that that power theorem that says when you have a power raised to a power you can just multiply the exponents, that only works for products. So the power theorem for exponents can be used only when a product is raised to a power. Well, that line's not long enough. When a product is raised to a power, not a sum. It doesn't work when there's a plus or a minus in between them. Okay? Now, we're doing more than squaring. You see in example 1, we're cubing this. And so you have to do it in stages. Obviously, if you can't square a binomial by just squaring the two terms you see in there, you're definitely not going to just cube the x and cube the 2. So this means x plus 2 times x plus 2 times x plus 2. We're using x plus 2 as a factor 3 times. And first, we're just going to multiply those two. Okay. When we do that, we have x squared plus 2x with the outer ones, and then plus 2x with these. And then 2 times 2 gives us 4. That was multiplying 2 of them. We still have another. I'm going to put it in the front. Multiplication's commutative. It doesn't really matter what order they're in. So now I'm going to have x plus 2, and then add my like terms here, x squared plus 4x plus 4. And I multiply again. Now I take x times all 3 of these, and 2 times all 3 of these. When I multiply x times x squared, I get x cubed. And then x times 4x is 4x squared. And x times 4 is 4x. Okay, now I'm taking 2 times each of these, and I'm going to line up my like terms. 2 times x squared, 2x squared, I'm putting below the other x squared. 2 times 4x is 8x, putting below the 4x. And 2 times 4 is 8. And then I just add these up. That's x to the third plus 6x squared plus 12x plus 8. And we're done. That's all there is to that. What's next? Okay, next is part B, where we're factoring. And the zero product property states, this is something you already know, if P and Q are any real numbers, and if P times Q is 0, then either P or Q is 0, or maybe both of them are. Could be, or both. Or both. They could both equal 0. So you know, if you're multiplying two numbers and the answer is 0, one of those factors had to be 0. We're going to use that property to solve some equations. Okay, so take a look at example 2. We are going to subtract 6 from both sides and arrange these in descending order of the exponents. So we'd have x squared minus x minus 6 equals 0. Okay? And now we're going to factor. So for the numbers, I need factors of 6 that I can subtract to get 1. So it's going to need to be 2 and 3. They need to be opposite signs to get the negative 6, and then I look here at the middle term at that coefficient to see which one's negative, right? The larger one has to be negative if I'm going to get a negative middle term. So 3 is negative, 2 is positive, and just a quick check, I get, when I FOIL this, I get x squared minus 3x plus 2x gives me the negative x minus 6. So I know that works. That's equivalent to the line above. And now I have two things getting multiplied. X plus 2 getting multiplied times x minus 3. And the answer is 0. That means one of those factors has to equal 0. So either this one is 0 or that one is 0. And then I solve them. If x plus 2 is 0, that means x is negative 2. And if x minus 3 is 0, that means x equals 3. It could be either one of them. And to write my answer, I could just circle that the way it is, or I could negative 2, comma 3. Don't write them as an ordered pair, though. They wouldn't go in parentheses. I'm just going to circle it like that. Now, to check it, I would go back to the original equation and put them in and make sure they work. So we have some space. I'm going to do the check over here on the right. And I want to go to the original equation in case I made some little mistake when I was moving things around. So to check for negative 2, that's the opposite of negative 2, that's 2, plus negative 2 squared is 4. Yes, that equals 6. I better put what I'm checking. Okay, and then trying 3. The opposite of 3 is negative 3. 3 squared is 9. That also equals 6. They both work. I know they're right. Okay, solutions to equations or inequalities are the numbers that make them true, make the original equation or inequality true. So you check with that. And then there is one more example, and then I guess we'll be done. Well, I might throw an extra one in here. Anyway, this one. We want to get everything on one side, and I guess it's less to move if I just add 35x to both sides. You could do it either way. Okay, so that means I have 0 over here. And on this side, I'm going to write these in descending order of the exponents. So I have negative x cubed minus 2x squared plus 35x. All right? And anytime I'm factoring, the very first thing I should always look for is the greatest common factor. And there is one. They all have an x. Also keep in mind you want your lead coefficient, the coefficient of the one with the highest exponent, to be positive. So when I'm doing my GCF, I'm going to also factor out a negative. So negative x, what do I take times negative x to get that? X squared. What do I take times negative x to get the second term? Well, 2x. And then this one will be negative 35. So let's just check. That's negative x cubed minus 2x squared plus 35x. And that matches up here. So now I need to factor this part. Okay, so I need factors of 35 that I subtract to get 2. So 5 and 7, because 7 minus 5 is 2. Okay, there'll be opposite signs again, because this is negative. And the larger one has to be positive so that I can get a positive middle term. So 7 is positive, 5 is negative. And again, you can at least in your head FOIL that. Make sure you get what's above here. Now I have 3 things I'm multiplying and getting 0. So any one of those 3 factors could be 0. So we have either that one, either x is 0, or x minus 5 is 0, or x plus 7 is 0. So x is either 0, or in this case it would be 5, because 5 minus 5 is 0, or in the third one here it would be negative 7, because negative 7 plus 7 is 0. And I would go to the original equation to check these. 0 equals 0 minus 0. Yes. Okay, and then take a little more work to check the others. But you check them, you can use your calculator, make sure all of them work. If they don't, you just go back and check your work and fix your error. But that's what we have for this. In the book, there is a part C that just says only 0 equals 0. And it's making a point which I think I'll demonstrate very briefly down here. So here's a bonus example. Example 4, we're going to say 2x squared plus 4x minus 70 equals 0. And there's not much space here, so I'll try not to take a lot of steps. But again, we need to factor this, and we always look first for the GCF. All of those are even, so we can factor out a 2. Okay, so 2x squared, 4x, negative 70. Oh, look, x squared plus 2x minus 35. This part's the same as example 3. We know how this factors. So 2 times x minus 5 times x plus 7 equals 0. And the whole point of this only 0 equals 0 thing is I now have 3 factors. 2 times that equals 0. If you get in a hurry and aren't really thinking about what you're writing, you might put, like you had up here, we had 3 different factors, any of them could equal 0. Please don't write that 2 equals 0. You know that's not true. Only 0 equals 0. That's the point of part C in the book. So I'm not dedicating space to that other than example 4 in your notes. Okay, the solution to this actually would just be, because we know 2 can't be 0, one of these would have to be 0. So either x is 5 or negative 7. And that's all you would do to that. It can't be 2. And again, if you took the time and do the check, you would see that that didn't work anyway. But that is now all there is to the 38 notes. I hope you enjoy.